So hello everyone. So myself Rumour from the Bennett University, and today I'm going to present my research work in the course for 2020. So let me share my screen. Okay. So my topic of today presentation is a approach. We can say RUEvaL20. It's about the improving rumor detection on social media using a deep convolutional neural network. Paper ID 186. It is a quick outline. First, I will explain the introduction, then subsequently related work, research objective, proposed methodology that we have used, implementation and result, and conclusion, final with the references. So if we talk about what are the rumors, so rumors are currently spreading very rapid rate in the connected world, and the microblogs are the emerging and the target victim for spreading the rumors on the social media platforms. So the terms, if you talk about the rumor, what is a rumor? So it derived from the Greek word pheme. It means unverified statement or fact. So rumor is unverified. It is not verified when it comes, or we don't know it's a fact or not. So people believe more towards a rumor without gaining the knowledge of this rumor, and it aligns with the existing beliefs. It follows the existing belief with the rumor. And if we talk about the efficient detection, so we can say in the area of AI and deep learning combined with the NLP is gaining more attention towards with the highest accuracy for a real world rumor data set. Few examples of rumors. The top right most is the buy the rumor, sell the news. So it's for the stock prediction. We often see this article or this in the newspaper. In the current pandemic of COVID-19, the different type of rumors are coming into the market. So it's about the eating of garlic prevent the infection of the new coronavirus. And one with the very famous rumor are spread, say according to 6 months or 1 year. It's about the HIV. At the most people spread the HIV. And a lot of research is being done on that. So these are rumors, and the source are the Facebook and Twitter from these images. So I have done an exploration about the existing work, and we found that either we have to go for the more writer style for the rumor detection, either we get or we build an efficient approach that for the better rumor detection. So this is the same existing work published in the IEEE transactions. So major scope is to combine the more features for the rumor detection system. The content, user propagation, the temporal features are there, user community feature are there, user individual features are there. So we can combine the different type of features, and we can increase the accuracy levels. So what research objective I have taken into a consideration? The first one, I acquire a real world data set for the rumor detection. Then customize the existing fake news rumor detection technique methods using deep learning technique. Build an efficient system for the rumor detection, and then validate the customized technique on a real world data set. So methodology, we have taken simple methodology that we have taken an input in terms of data and data processing we have done, and tokenization we have made, then splitting the train test data split 80-20-20, and use a glove word embedding for the pivot train word embedding, training and testing. Accurate analysis of all implemented model that we have used in the deep CNN, LSTM, and the finally output that we achieved. So PHME we consider a standard benchmark for the rumor detection, that is the PHME. So total number of instances are 1,03,211, in which 31,000 are real fake and 38,000 are real. So what proposed framework that we have taken into consideration, that in our proposed framework we have used a deep convolutional neural network in which, and one thing I want to explain, that in the total PHEME dataset we have the annotated based on the very true, false, or unverified. So false is true, true type of news, real is true, false is the false, and the unverified also in the Rumour dataset. So we come to the proposed framework. So we take a embedding layer using a pre-trained word embedding. Different kernel sizes. Convolutional layer we have taken into a single parallel channel. That is convolutional 1 kernel size 3, convolutional 2 is kernel size 5, and convolutional 3 is kernel size 7. And finally, we have taken the convolutional 4, then a kernel size 9. So different kernel size for the better efficient learning for the input embedding vectors, and that is a more that provide the more efficient result. If you take different type of learning to a model, different type of length input vector learning for the time model, so it can increase the accuracy level because it's capable of more type of automatically extracted feature that are more capable in with the length input vectors. So with the max pooling layer, different type of operations are coming, and then we have used the flatten layer. And after the flatten layer, we have taken the 3 dense layers with the different type of filters 128, 64, 32 with the same dropout value, and dropout value will be vary from 0.1, 0.01 to 0.02. So with this architecture, when we applied from different type of model and with the Rumour PHEME dataset, we get the more accurate result. It's 88.90 with the our model Rumour RUEvaL20 with the PHEME dataset. Existing model are also providing the good accuracy SAC and NN, that is over 82.70. But when we type of different type of kernel sizes with the different type of kernel sizes, convolutional layers, and with the dense layer with a different number of filters, and we designed a such type of network, so it's providing a more accurate result. So with this, we can the conclusion that user base is increasing on the social media. The volume of content is growing rapidly. So it's a lead to more reliable content available on the social media things. And our research is more focused on the effective detection technique for the Rumour detection using the deep learning techniques. The stress is more on the Rumour detection, and the result in improved Rumour detection with our proposed model Rumour RUEvaL20. So with this note, I end my meeting. So if anybody want to ask any question, so I'm happy to give the answer. So thanks everyone. I stop my sharing.